Okay, we're on to question number 5 from this part, and they give us f of x, and I went ahead and solved for f prime of x. Feel like that's going to be needed somewhere down throughout the problem. Of course, I cheated by working the problem in advance, so yes, it is going to be needed. First problem, just ask about, okay, is this function continuous at 0? Remember, there are 3 stipulations for a function to be continuous at a value. The value must exist. Okay, well, f of 0 is 0. Okay, so f of 0 exists. So now I'm going to check for the limit. The limit, and since it's at a break, we have to consider the left-hand limit and the right-hand limit. Well, the left-hand limit we just solved, it is 0. The right-hand limit is 2 times e to the 0, which is 1. No, yeah. I went to the derivative instead. Sorry. E to the 0, which is 1. 1 plus 2 is 3. So, the limit as x approaches 0 does not exist. So, therefore, f is not continuous at 0. All right, so that's part A. Part B is, what is f prime of -2 and what is f prime of 3? Well, to do these derivatives, again, it's a piecewise function, so we have to consider which equation to use for the particular domain value. For f prime of 2, that falls into this category of the 6x plus 2, so it's 6 times -2 plus 2, which is -10. And then f prime of 3 is 2 times e to the 2 times 3 power, which is just 2e to the 6th. And you don't know what e to the 6th is, and you don't have your calculator for this problem, so you would just leave this problem like that. On to part C. Explain why f prime of 0 does not exist. Well, f prime of 0 does not exist because f of x is not continuous at x equals 0, and continuity is a requirement for differentiability. So, that's going to be parts A through C. On to part D. Part D is asking about g of x, and it's defining g of x as being the integral from -1 to x of f of t dt. And it wants to know what g of 1 is. Now, typically, in one of these problems, they start asking about g prime. But it's not the case in this one. So in this one, we know that g of x is going to be the integral from -1 to 0 of f of t dt plus the integral from 0 to 1 of f of t dt. So the integral from -1 to 1, okay, so we've got, all right, g of x is going to equal to the integral from -1 to 0 of, all right, that's going to be 3t squared plus 2t plus the integral from 0 to 1 of e to the 2t plus 2 dt. Again, you're looking at two different equations. This one covers from -1 to 0. This one covers from 0 to 1. And one other thing I didn't really emphasize earlier is continuity is not required for being able to take an antiderivative. This function is not continuous at 0, but that's okay. You can still take the separate areas of those values. So g of x equals, all right, this would be 3t cubed over 3, so it would be t cubed, 2t squared over 2, which is just going to be t squared. All right, then plus, all right, the antiderivative here, if you let u equal to 2t, then du over 2 would equal to dt, so it's 1/2 e to the u, and u is 2t, so it's 1/2 e to the 2t plus 2t dt. And we're going from 1 to 0. All right, so so from -1 to 0, you've got, well, 0, and then this would be -1 plus 1, so that's going to be 0, plus, all right, this becomes 1/2 e squared plus 2 times 1. All right, then minus. Now remember, when you're dealing with cosine and when you're dealing with e, when you plug in 0, you do get a number other than 0 as the answer. So we have 1/2 of e to the 0, which is just going to be 1/2. So we get 1/2, oh, and then 2t would be 2 times 0, which is 0. So we have 1/2 e squared plus 2 minus 1/2. So 1/2 e squared plus 3/2. And that's going to be the solution for problem number 5.